All right, good morning, everyone. Today is March 27th. It is Friday. And today, what we're going to be doing, sorry if this is all going a little bit hectic here. Uh, Today, what we're going to be doing is we're going to be going through the rest of the Chapter 7 study guide. So, we're going to go ahead and start now. I don't know if this is recording. Let me just make sure it is recording. Okay, good. It is recording still. All right, so we're going to go ahead and go through number 14. 14 is actually the last one I want to go through. 15 is all special cases, and right now I don't think that special cases is really worth our time. I'm going to be uploading another lesson soon, so I don't want you thinking that it's going to be more difficult. So we're going to start with number 14 here. Number 14 is called factor by grouping. Now, the reason this is so important is simply factor by grouping is what we did with number 13 right here, where we factored the trinomial and we found two binomials. So we're going to do that again. 14, the reason 14 is so difficult is because our first step is going to be finding A, B, and C. And remember, when A is 1, it is really easy. However, if we look here, A, B, and C, we can go ahead and find A. A is in front of K squared, which is 2. B is in front of K, which is 5. And C is at the end. It is alone, so it's going to be negative 3. Now, the reason I think it's really important to point this out is that A is not 1. When A is 1, factoring is really simple. When A is not 1, it's very, very important that we do it correctly. So we're going to go ahead now, and we're going to do what they suggest, which is factor by grouping. Take A, multiply it by C. So we're going to go ahead and do that. So I'm going to take A times C. All right, A is 2. A is 2. What does that keep happening? C is negative 3. And as you all know, 2 times negative 3 is negative 6. Now, what we're going to do is very similar to what we did up here in 13, where we took our number and found the factors of it. So we're going to go ahead and find the factors of negative 6. So it's a negative, so it's going to be a little more tricky, but we're going to take it slow. So we're going to say, all right, negative 6 has factors 1 times negative 6, negative 1 times positive 6, 2 times negative 3, and negative 3 times positive 2. Oh, I'm sorry. That last one got away from me. I'm going ahead of the curve. It should be negative 2 times positive 3. All right. So what we're going to do now, just like 13 above, and if you weren't here for number 13, go ahead and go back and view my last video. But the next thing we're going to do is find the sum of each of these factored groups, and we are going to go ahead and say what they equal. If they equal B, which is 5, we're going to choose that sum. So I know B is positive 5. So I'm going to add up all of our factored pairs right here. And I'm going to see which one adds up to a positive 5. So 1 plus a negative 6 is actually negative 5. Negative 1 plus 6 is actually positive 5. Now, my last video, I talked about double checking work. Please double check your work. I could have made an error. So I'll keep going. 2 plus a negative 3 is negative 1, and negative 2 plus 3 is positive 1. All right, so now I know that there's only one solution. My solution can only work when my factors are negative 1 and positive 6. So what I'm going to do right now is I found A times C. I'm actually going to go ahead and split B. So we can agree that negative 1 plus 6 is the same thing as 5. This is what we found right here. So instead of saying 5k, I'm going to say negative 1k and 6k. Remember, negative 1 plus 6 is 5. So all I'm really doing is I'm changing the equation. So instead of 5k, I'm going to write minus 1k and then plus 6k minus 3. Now notice, the reason I did that, negative 1k plus 6k is still 5k. So I know that this equation is still the same. But the reason I did that was really so that I can go ahead and figure out how can I split k up to make common factors. Now, my next step is actually I want to take this whole line right here, and I'm going to put parentheses around it and really make it just two binomials. So I'm actually going to go ahead and rewrite it, and I'm going to go ahead and put parentheses around 2k squared minus 1k. And then I'm going to go ahead and put parentheses around 6k minus 3. So the reason I did this is because now I can factor out common terms in each of these parentheses sets. So that's what I'm going to go ahead and do. I'm going to break down both of my parentheses and figure out what each of these terms have in common. So I'm going to start with the first one right here. I'm going to start with the first one right here. And I'm going to say, okay, what do these two terms have in common? So what I'm going to do is I'm going to break it down. I'm going to say 2k squared really breaks down to 2 times k times k. Minus 1k really just turns into minus 1 times k. And we can notice that they both have in common a single k. Each of them have a k. So I'm going to pull the k out in front and write the leftovers. So 2k minus 1. So 2k minus 1. So that's it. I really just wanted to find the common factors in that parenthesis. Now, what I'm going to do next is I'm actually going to go ahead and do the same thing with this second set of parentheses. So I'm going to break down 6k minus 3. So 6 I really know is just 2 times 3 times k. So 6k is really just 2 times 3 times k. Minus 3, I'm actually going to break down. I'm going to say minus 3 is actually negative 1 times 3. And we know negative 1 times 3 is just negative 3, so that makes a little bit of sense. So what I'm going to do now is I'm going to find the common factors in this parenthesis set. And that's exactly what I did in the first one. So notice that they both have a 3 in common. So I'm going to remove the 3 out in front. I'll say plus 3, and I'll write the leftovers, 2k minus 1. All right, so now that I have that done, I can notice something really cool. I noticed that my leftovers, and I'll underline these in orange here, my leftovers right here, 2k minus 1, they are the same. So I know I did it correctly. So what I'm going to do now is I'm going to write the greatest common factors. I'll take those, which are k and a positive 3, and I'll put them together. K plus 3, and then I'll multiply it by my leftovers, or the underlined in orange, so which is 2k minus 1. So what I really did there is I said, okay, what do each of these have in common? And then what can I remove to make it make sense? Now, how do I know this should be my answer? How do I know that this is my answer? How do I know it's correct? Well, I can actually use my box method to check. So I'm going to go ahead and do k plus 3 times 2k minus 1. And I'm just going to go ahead and see if I get my original problem right up here, 2k squared plus 5k minus 3. So 2k times k is 2k squared. Negative 1 times k is negative 1k. 2k times 3 is 6k. And 3 times negative 1 is negative 3. So I know it should be 2k squared minus 1k plus 6k minus 3. Well, if I combine like terms, I know I will get 2k squared. Negative 1k plus 6k is plus 5k minus 3. So this is the same thing I started with, which means that k plus 3 times 2k minus 1 is our answer. So we know that this works. All right. I'm going to go ahead and move over to 14b. We're going to do the same thing again. So first things first, I'm going to go ahead and identify A, B, and C. So I'm going to go ahead and say A, B, and C. Okay. A is 3, B is negative 20, and C is negative 7. So I'm gonna start by doing A times C. Well, A times C, 3 times negative 7 is negative 21. There are only a few sets of factors for negative 21, so I could either have done 1 times negative 21, negative 1 times positive 21, 3 times negative 7, negative 3 times positive 7. Well, we want to figure out which set adds up to negative 20, or B. So 1 minus 21, well, or I'm sorry, 1 plus negative 21, that's actually negative 20. All right, now, I know a lot of you thinking, well, I'm going to stop because obviously this is correct. Just check. It takes a second of your time. Just check. So negative 1 plus 21 is positive 20. Okay, clearly not it. 3 plus negative 7 is negative 4. Clearly not it. Negative 3 plus 7 is positive 4. All right, so I know my factors. How I'm going to split B is 1 and negative 21. All right, so this is the trick, or this is the part that a lot of people get confused about. All right, and I'm trying to change my pen color so you can see it. Let's try and change it a different color. All right, that's not going to work. All right, what color do I got? Light blue? That's terrible. All right, I guess we're doing it in light blue. So what we're going to do is we're going to write 3f squared, and instead of negative 20f, we've agreed that 1 minus 21 is negative 20. I'm going to say plus 1f minus 21f minus 7 is how we're going to rewrite this. Now, I'm going to go ahead and group these with parentheses. I'm going to say parentheses 3f squared plus 1f. And then I'm actually going to go ahead and say plus negative 21f minus 7. And the reason I'm doing that is because I always like to have a plus right in the center, all right? So let's go ahead and we're going to find what these have in common. Well, 3f squared can only be broken down to 3 times f times f. 1f can only be broken down to 1 times f. What do they have in common? They have 1f each. So we're just going to pull an f out and write what they have left over. They left over 3f plus 1. All right, now I'm going to go ahead and I'm going to break down negative 21f and a negative 7. So negative 21 can break down to a few things. First off, we know that negative 21 can actually break down to negative 7 times 3 times f. Negative 7, I'm actually going to break down to two things. I'm going to say it is 1 times negative 7. And the reason I'm doing this is because I'm actually looking a bit forward. I'm saying, what am I going to be having in common? So if I look at negative 21f and negative 7, I know that they both have a negative 7 in common. So I'm actually going to remove the negative 7, put it in front, and I'm going to talk about what they have left over. They had left over 3f plus 1. So 3f plus 1 is our leftovers. By the way, I do think I'm getting Thai food tonight. I'm super excited. I want to check to make sure my leftovers are the same. My leftovers are right here. My leftovers are 3f plus 1 in both measures, so I know that that's correct. I'm going to take what they had in common, or I'm sorry, I'm going to take what the greatest common factor of each, and I'm going to put that in its own parenthesis, so f minus 7, and I'll put one of the leftovers behind it. And as always, it is good to check your work. So we're going to go ahead and do f minus 7 times 3f plus 1. So 3f times f is simply 3f squared. 1 times f is simply 1f. Negative 7 times 3f is simply negative 21f. And negative 7 times 1 is negative 7. If I write this out, I should get 3f squared plus 1f minus 21f minus 7. And if I combine like terms, 1f and negative 21f are simply going to add up to negative 20f. And this is what I started with. So I know f minus 7 times 3f plus 1 is our solution. So I would go through C and D, try it, ask me questions, but this is all I'm going to go through today, all right, with you. Frankly, I'm having some tech issues and want to make sure that I didn't mess up anything too badly. But the rest of this, 14 and 15, honestly, we've talked about it in class. We limited our exposure to it, so I don't particularly want to go over it too much. Try 14C and D on your own. If you have questions, please feel free to ask me. Otherwise, that's all I have for you today. There will be new stuff coming, so please look for that. I'm really excited for it. So if you're watching these videos and staying on top of things, I expect that you'll be really good when we come back and are back in classes. So that's all for today. That's actually it for the Chapter 7 study guide. If you have any questions, please feel free to email me. And as always, stay healthy, wash your hands, and I will see you all soon.